Good morning, this is your Stats Sensei, Mr. Spensei, and in this video, we're going to talk about the inverse norm. So previously, we took z-scores for the normal distribution and calculated probabilities. In this video, we're going to have probabilities and go back and calculate z-scores. So it says, what are the z-scores associated with the middle 68% of the data? Well, the picture is going to look something like this. We're looking for a z-score, so our center part is 0, and we should be 0.68. And technically, we know we should be plus or minus 1 standard deviation. And what I'm looking for is that area right there. All right? So I'm going to look for a lower bound, and I'm going to look for an upper bound. Now, I'm going to do this the hard way once, but only once. The hard way is I'm going to do an inverse norm, and I'm going to find this area coming from the left. So second vars, inverse norm, area, that's going to be 1 minus 0.68, close parenthesis, divided by 2. All z-scores have a mean of 0, standard deviation of 1. I want the left-hand side. And I obviously did something wrong. 1 minus 0.68. Divide that by 2, and I should get 0.16. So this area right here should be 0.16, and this area right here is 0.16. So second vars, inverse norm, clear, 0.16, mean of 0, standard deviation of 1. And I get a z-score, of not quite 1. That's right. That's why that looks funny. So z equals negative 0.9944. That's my lower z-score right here. If I do the upper z-score, second vars, inverse norm, and I want the upper part, I'm going to be coming from the right. And I get 0.944. So this Z1 right here and Z2 right here, negative 9.9944 and 99.44 or 0.9944, excuse me. But the easiest way, and the way I'm going to do it from now on, is second vars, inverse norm. My area, what did we want? We wanted 68. Mean is 0, standard deviation 1. If we just press center on this calculator, boom, there it is. We have our lower bound and our upper bound. And that's what I got, doing it the hard way. So what z-scores are associated with the middle 95%? Well, that should be about plus or minus 2 by empirical rule. Now we know the empirical rule is just an approximation, but I want 0.95, and I'm looking for a lower z, z1, and z2. So I should have two numbers. So second vars, inverse norm, change that to 0.95. All z-scores have a mean of 0, standard deviation 1. We want it centered. And we end up with 1.9599 and positive 1.9599. So negative 1.9599 and positive 1.9599. Those are my z-scores, and that's centered up. What are the z-scores associated with the middle 99.7? So we should be plus or minus 3 standard deviations. That was plus or minus 2. And we're out here at 0.997. And I'm looking for the Z1 and Z2, centered at a mean of 0. Second vars, inverse norm. 0.997, centered. And we're almost 3. We're at negative 2.9677 and positive 2.9677. Now we're looking for the middle 80%. Which is not one we know, and we can go second vars, inverse norm, just change that to 0.8. And once again, we're centered because we're looking for the middle. And we get negative 1.2815 and positive 1.2815. Notice that once we found one, we really knew the other because we are symmetric. All right, all we had to do is change the negative to a positive and we're good to go. All right, well, that takes care of that part. So that's with centered about the mean using percents. But what happens if we actually have actual scores? So for the following questions, the population is normal with the mean of 79 and standard deviation is 7. So we have mean is 79, standard deviation of 7. A student claimed to have scored at the 99th percentile. What is the score? Okay, so z equals x minus mu over sigma. And we have to show all of this work. Okay, now I'm going to let the calculator do the hard part for me, but we still have to show all the work. So he claimed to be at the 99th percentile. So this area right here is 0.99. Okay, 0.99. We don't know what this value is right here. We know that our mean is 79. Well, I can plug in. We don't know the x. We do know the mean is 79. And we do know that the standard deviation is 7. Now, I don't have the 99th percentile, but I can get that z-score by doing an inverse norm. So second vars, inverse norm. Now be careful. I'm coming as a percentile, so I'm coming from the left. So I need to make sure that I have it from the left, 0.99. Z-scores, all z-scores are 0 and 1. We're coming from the left. And I have 2.3263. Now I can solve this using algebra, but as opposed to doing that and taking a chance of making an error, I'm going to go back and rerun it. I'm going to do a second vars, inverse norm, 0.99, mean of 79, standard deviation of 7, still coming from the left. And look, it tells me that it is 95.28. So X is 95.2844. A student claimed to have scored at the 25th percentile. What's the score? Well, the 25th percentile is definitely less than the mean. The mean right here is at 79, and he's got about 0.25, and we want to know the score. So once again, z equals x minus mu over sigma. And we don't know what x is. We do know the mean is 79. We know this is 7. The standard deviation is 7. So we're going to jump in there and calculate the z-score, second vars, inverse norm, 0.25, coming from the left. We need to turn this to 0 and this to 1. It's real important we get that z-score. And we get negative 0.6744. And it makes sense that it would be negative because we are below the mean. Now, once again, I can solve that by algebra, but I can do it much faster and safer by going second vars, inverse norm, 0.25, mean is 79, standard deviation is 7 coming from the left. And we get that they scored a 74.27. X equals 74.2785. The upper 10% of students are associated with scores above what? So they said above, so 10%. Oh, that's above, so I'm coming from the right. So this is 0.10. Once again, we're set at 79. This right here is 90%. So you could come from the left at 90% or from on top at 10%, but we're looking for this and we're looking for that score right there. So Z equals X minus mu over sigma. And I'm going to intentionally make a mistake on this. I'm going to go second vars, inverse norm. I'm going to put 0.10. Mean is 0, standard deviation of 1. Or excuse me, yeah, that's right. And this is going to be X minus 79 over 7. And this is how important having the picture is. So I have a negative z-score, and it's like, wait a second, that can't be right. I'm above the mean. Instead of being a negative 1.28, it should have been a positive 1.28. And so second vars, inverse norm. And if I turn that into a right and keep the 10%, I get 1.2815, the positive value that I needed. Once again, I could have solved this by algebra, but I'm going to choose to let the calculator do the work. So what I'm paying it to do, second vars, inverse norm, and change that to 79, standard deviation to 7, keeping it right. And I end up with 87.9708. All right, the lowest 10% of students. So now we're talking about the lower 10%. We're still centered at 79, and I'm looking for this X value. Z equals X minus mu. So X minus the 79 over 7. And it should be just the opposite of that. Second vars, inverse norm, 0.1, mean is 0, standard deviation of 1. But we're coming from the left, and it's 10%, so I'm at the lower half. So sure enough, I get that negative z-score. And we're going to go back and go second vars, inverse norm, and change that to a 79 and this into a 7. And we get 70.0291. Finally, 80% of the students scored above what? So this is a confusing phrase. So X, 80 is above it. This is 79. 80 is coming above it. So I need over halfway. And that's the X value I'm looking for. And I'm looking for this 80%. So I can come from the left at 20% or from the right at 80%. I'm going to come from the right because that's what they phrase in the question. Z equals X minus mu over sigma. And X minus 79 over 7. Now I'm over halfway. I'm on the negative side, so I better get a negative z-score. So second vars, inverse norm, 0.8, mean is 0, standard deviation of 1, coming from the right, because we came from the right, we came from the 80 percentile side. And I get a negative 0.8416. Solved by algebra. And I'm just going to change this to 79 and this to 7. Press enter a couple, oops, don't want that, want to stay right. And then put 73.10. Well, that makes sense because I should be below the mean. And sure enough, X is 73.1086. All right. Please note, we should be 73.1086. Oh, yeah, that's the way I drew it. That's below. 70.0. Oh, that's below it. Should be. 87. Oh, that's above it. It should be. That's the way we drew it. 74. Oh, that's below the mean. That's the way we drew it. All right. 95. That's above the mean, and that's the way we drew it. All right. I appreciate you watching. I hope this helps, and I hope to see you on the next one. Thank you.